Okay, good morning. I think we should start with our presentation. My name is Marlene Luckner. I'm the marketing manager from ACAM Systemautomation, and I wish you a warm welcome to our seminar about Simcenter, simulation and testing. As an innovative company, ACAM is supporting its customers since 1994, primarily in the areas of product development and manufacturing. ACAM offers integrated solutions that cover all phases of the product lifecycle. As top partner with the Smart Expert status from Siemens Digital Industries, we have round about 40 employees and 3 locations in Austria. And do not only offer you the extensive portfolio for software and hardware from Siemens. On top, we propose services from professionals who support you or can do the simulation and testing for you. ACAM Systemautomation and its subsidiary ACAM Engineering are the perfect combination between software, hardware, and service provider. Today, Jean-Pierre Riot will present us Heeds and a short overview about the chances for your business. Please mute your microphones and post questions in the chat. We will answer their questions after the presentation. This presentation will be recorded.
So thank you very much again for the ability to present Heeds, which is part of the Simcenter solution from Siemens Digital Industry Software. I'm just sharing brief agenda of what we'll be talking about during this next half an hour. So I'm Jean-Pierre Roux. I said I'm part of what we call Global Heeds PFD's team, and I'm focusing on EMEA for business development. So the agenda is, let's talk a bit about what is about design space exploration. What does it mean? What is Heeds MDO, the tool we will talk about today? And then we'll share some application example to help you to figure out how this could be used in your company, how it could help you. And then we could, at the end, wrap up and address some questions you may have. And that's what we're going to do for the next 30 minutes. And starting with what is design space exploration. And this is also linked with what we call multidisciplinary design analysis and optimization. So if you look at this graph, what we try to represent is how simulation adds value over the way you're using it. And if you start from the left-hand side to the right-hand side, the more you're using upfront simulation, the more proactive you are, and the more value you get out of the simulations. It means that if you use simulation upfront for improving your product, you'll get more chances to have a good product when you go to physical prototyping and testing. And today, there are excellent tools on the market, including those from Siemens. More and more engineers are trained to use so-called finite element analysis and derivative of it, such as you'll be able to create methodologies, create approaches using simulation in order to create your digital twin. So even though we still assume that model calibration is useful, is still needed to make a trustful digital twin, most of the company now have predictive models. So the next stage is when you have methodology in place using certain simulation tool, CAD tools to create your digital twin, there is opportunity to move to the next step, which is what we call automation. What we call about automation is a way to capture what you're doing today manually, meaning using one tool, inputting some data in it, creating models, exporting data to another tool, and so on. If you can create automation of that, of course, immediately you understand you have benefits because you will spend less human time on this. So automation, basically, you could think about using it on those repetitive tasks that you're using every day when you're designing your product, when you're or the designing itself, the layout of a plant. This is things that you do every day. You could think to automate it, right? Because you're spending human time to do exactly the same tasks. Automation is very much helpful here. And also the benefits of using automation would be to remove human errors in a way that if multiple persons are using the same methodology, there's still chances that some human error are being done. And in that case, your models may not be predictive at the end. So automation by itself has a lot of value, but this is a necessary step for moving to the next step, which is what we call exploration. Exploration would be how could you now take into account all the variables you have when you're designing a product, when you take into account all the constraints you have, taking into account the objective you have to meet from your specs. Well, there are different techniques to explore the design space. You could just do it manually, and you could also think into using some smart search techniques. And this is what we'll show today, that if you manage to give you a smart search technology, easy to use, that will search for you the space based on your input, that will again free up your time, but actually give you more time to explore designs found by this technology. So that looks a little bit theoretical to you now, but let's dive into more details. What you see here is typically what most of the companies are doing today when they're doing manual step-by-step try and error approaches when they're using simulation, but they would do the same if they use automation, right? If you automate a process, again, that's a lot of value because you will not spend human time. Everything will be executed in the background, but still you will do step-by-step approach. So you always have to meet requirements or objectives, as you see here, and you always start from what we call a baseline design, right? This is your first design that maybe it comes from the former generation of your product, or that comes just from out of your experience. You start with the first design. You apply your methodology of simulation manually or automatically, and then you figure out how it behaves. Then, based on how it behaves, you will do some tweaks, some changes on the parameters that define your product. That could be geometry, that could be material, that could be, I don't know, anchor point locations. And so you will navigate in the design space smartly while we think about it, right? But you'll at some point it will stop, right? You do some iterations and then you're there, and you improved from the red point to the pink point. You improve the performance globally, but you never know if you really reach the limit, if you couldn't have done a better way. Also, our human brain has some limitations. Let me explain that. If you have, let's say, 10 parameters that you could play with when you're designing your product, again, parameters about the geometry of your product and or thicknesses and or materials and so on, well, you cannot humanly manage that. You cannot change all the parameters at the same time, and you wouldn't be able, what is the effect of changing one variable on the performance? So that's the limitation of this, let's say, based on experience approach. On the opposite side, what we will propose here is a direct exploration method using Heeds and Sherpa, which is our internal search technology I will detail later on. And in that case, you will start differently how you will focus. You will focus on the objectives. You will focus on what are the parameters you want to change. And that could be, again, shapes, materials, thicknesses, and whatever is driving is in your simulation file or in your CAD file. And you will set the problems. What are my objectives? And here the technology has no issues with driving changes of a large number of parameters. If you have a large number of parameters, there are, of course, more chances to have the right combination of those parameters and get a very performing design. So you start again from a baseline design, but here the technology will search automatically in the background, running 7 hours a day, 7 days a week in the background on your machine, on your cluster. And it will thoroughly search the space and come to you with multiple solutions from which you will be able to make some trades off. So that's really the difference between those two approaches. I will detail how we can do that. A first example from one of our clients called Multiwing Group. Their one part of their portfolio of product is about axial fans for cooling system from different industries, heavy machinery, trucks, but also different. And typically, they're always looking to have very efficient fans, of course. And for that, in their particular case, they're using when they're designing and want to evaluate the performance of a given design, they're using SolidWorks as a CAD solution. They're using StarCCM Plus for evaluating the flow efficiency. And what has been done here is they've been using Heeds MDO, our tool, to automate this process. And again, we'll see later on how we do it. So the typical problem they have to face is minimize the torque, of course, of their fan, because more torque means more energy consumed. But also they want to maximize mass flow, which is the performance you could get out of an actual fan. They have a lot of constraints, of course. Every client, every industry, every company has constraints. You can not fully design a product. You have to take into account those constraints. Here, those are maximum allowable torque, but also the minimum required mass flow. And they have 24 design variables, which are actually defining the geometry of their fan. So if you look at the pictures on the right-hand side, you see that there are different fan geometry, and they are defined by the camber angles, core lengths, spine lengths, and also number of blades. Again, here it's about looking at what is the best design, how many blades, what are the shape of each blades to meet those requirements. So with our technology, and we'll detail later on how we do that, we're able to automate the execution of the first design, which is the red dot on the upper left corner of the graph, and the solution searched the space behind the scene and came out with different solutions that were meeting the requirement. We'll see later on that this technology can apply to very different applications. Also, everyone is, of course, talking about innovation. I think every company is convinced that innovation is something you have to drive in your company, such as you keep at the front of the market. You come with solutions, new solutions, innovative solutions, and if you think about design space exploration, that can help you in that way, because if you set the problems quite open, it can suggest you design you've never thought about. I've got some anecdotal terms that few clients had talked with us saying that, with Heeds, we found solution we never thought about in the past. And they came with very innovative solution that helped them to perform well on the market. Also think that if you free up some of your time, not doing manual tasks, manual changes of your design, but you spend more time into analyzing the designs that were evaluated by Heeds, you have more chances to find better solutions and innovative solutions. So what is Heeds MDO? So this is a solution framework which will help you to perform multidisciplinary design analysis and optimization. And this could be used, and this is used mostly by designers and engineers who are using simulation along with CAD solution, and we'll show you now how we do it. So I talked a little bit about Simcenter earlier, and what you see here is what we call the Simcenter wheel with the different domain. There is the system simulation with different 1D based simulation tools, like Simcenter AMSIM, for example, or Flowmaster. Then you've got the mechanical simulation, CFD, EMAG, different solutions you may have heard about or you're using, and then all the physical testings. Heeds MDO is a transversal product in a way that it will be able to connect to those tools to create automation of these tools, automatic execution of these tools, one tool or multiple tools combined, including physical testing. So this is where Heeds MDO lies. So connecting to Simcenter, but not only, of course. We admit that all clients are using different solutions from the market. And you can see that Heeds MDO connects not only to the Siemens Simcenter solution, but also to other solutions from the market you may have seen or you may be using as well. And the idea here is that we want to have a non-disruptive technology. You're using, for example, Abacus or ANSYS at this time, fine. We can create the same way the automation we're doing with Simcenter as well. And then you can combine the different tools. So you can see different simulation solution, different CAD solution. I mentioned earlier SolidWorks, CATIA, NX, of course, Solid Edge. The idea is that, again, you can use those on-the-shelf connector to create the automation of of a given tool. Well, if a certain tool is not in that list, and in the simulation world there are actually lots of different tools on the market. They are the major one, but lots of others. We have what we call the generic connector. In this generic connector will help you to create the automation for any software, any application, even your in-house solution you may have developed, provided few requirements like this solution has to be able to be executed in a command line, and we need to have access and read the input-output file, such as we can set where are the variables, where are the performance data. So basically, again, this is an open solution. Each release comes with additional on-the-shelf portals, connectors, but we've never been able to develop all the portals for all simulation solution on the market. So that's the generic portal that is there to make the solution for that. So if we detail now how we will create automation, how we will explore the design space, we will do it according to four major pillars. The first one is the process automation. And you see in this little video that we have all those connectors I showed earlier, and you can use it with the drag and drop approach and recreate on the fly your workflow. So in that example, maybe a little bit small on your screen, you see that there is from left to right, there is an NX CAD, then there is a Star CCM Plus, then there is some Simcenter, then there is a specific brown square, which is the generic portal, maybe for a specific application, and then there is Excel. Excel is always somewhere when you want to process results. So what we're doing here is we're creating maybe what the user has been doing manually, meaning, I have a CAD in NX CAD, I will export it into a step file, then I will import it into Star CCM Plus, I will create the mesh, all the CFD simulation, then I will output some, let's say, for example, stress field, not stress, but maybe a thermal field that I'll be using as a starting point for mechanical thermal simulation in Simcenter. Then I will export data from Simcenter into my analysis specific post-treatment, and then finish analyzing things in Excel. I think this is, maybe you could say, well, this is extreme, maybe not. Lots of people are using different tools, but again, they're doing all of that manually. So what we see here is that we're capturing the workflow, and we will tell Heeds where are the input files, output files of each of the software, and we will create the automation, such as, again, once it's created, it can be executed automatically from left to right. If you want to execute multiple analysis in the same time, you want to assess for a given design the flow performance and the stress performance, you can do that as well. This is how we do it. So that's a bit quick, but that's a first overview of how you create automation. Again, very, very easy to create. And once it's done, you can capture that in a template that can be shared to your other colleagues, such as they will use the same template, automation template, to create a model. So once the automation is created, we give you a way to leverage all the computation power you may have from your local desktop machine or laptop to clouds through, internal clouds like Cluster or external cloud. And for that, we have direct connectors to job schedulers, for example, if you're using like LSF, PBS, Slurm, Or if you want to leverage Rescale or leverage Amazon Web Services, we have connectors on the shelf, such as you can again submit the heavy simulation on those powerful machines. Everything is set again to help you to use your machines or any power you may have to have the study executed more quickly. So once you have defined your strategy of where you will compute each part of the process, and again, and some of the part could be done on the Windows environment, some could be done with Linux. Heeds can orchestrate that, no issue. Can orchestrate execution of certain tools on Linux, certain files, and certain tools on Windows. Works very well. Then you will have to define what is your strategy when it's about designing, exploring the design space. And for that, we come with different approaches. We'll detail more. We've got solution for using some optimization techniques. We've got solution for performing design of experiment. And we also have solutions for assessing how reliable or robust is a given design. This is something you would assess after you found a good performing design. So there are different strategies of searching the design space in Heeds, and we will focusing on the proprietary solution for searching the design space, which is inside Heeds. Last but not least, when you think about having executed everything, you will now spend more time, and this is what our users are doing. They spend more time into the last part, which is we call insight and discovery. This is where you will have access during the study, or of course at the end of the study, to all the performance data in a self-contained environment. So it means that in that Heeds post environment, you will collect all the data you asked Heeds to collect. Could be, of course, graphs. Could be, as you see, some pictures of each design. It could be stress plots of each given design. So lots of different ways to analyze the changes, analyze why a design is good, why it's not good, and make decision out of it. So lots of tools, again, to post-process a lot of data that you may have hard time to do by yourself manually. Here, again, lots of tools to understand clusters of solutions, understand, again, why this design is good or why it's not good. So lots of data mining tool, again, that you'll be using to maybe select 1 or 2 or 3 performing design you could share with the project team. I talked a little bit earlier about technology for searching the space. Maybe you've got some experience using so-called optimization, parametric optimization. And we'll show you here that Heeds has a specific ingredient that makes things easier and life easier for engineers. We come with a solution that makes such that the engineer is focusing on designing product and not focusing on the optimization algorithm by themselves. So the traditional process is maybe the one you have heard about or maybe used in other solutions. It always starts with your first model, your digital twin, and you will define objectives, of course, and you will want to define variables, right, or parameters you will want to change. But if you use this traditional process and traditional technology, you will hit, let's say, a threshold. You will hit a stop, which is if you define too many variables, this technology cannot address it. For those, again, who have experience, you will never perform more than DOE with more than 10 variables. Doesn't make sense. You won't solve it. So you will have to restrain your design space already, limit the number of variables based on certain assessments, which are, I won't detail it here, which are maybe not that good. So you will have to make simplification either of the number of variables or you will have to create what we call a mathematical approximation of your real model. So you're about to optimize not on the real model, but on an approximation of it. We call that surrogate models or response surface models. Anyway, this requires, there is a learning curve for that, and this requires to be very cautious to have a surrogate model that really duplicate the real behavior of your digital twin. So once you've done that, you've got to select algorithm, and there are a lot of algorithms coming from academic research, and you may hear about gradient search, genetic particle swarm, so lots of different algorithms. Well, the bad news is none of them behave the same way and will solve all the problem you will want to solve, right? Each have a specific application and domain of excellence. So you have to understand and learn how they behave, right? So you've got to focus a lot of time into what is the difference between those algorithms. And then you have to tune those algorithms. That's the second bad news. Each of these algorithms come with mathematical parameters to tweak, and you got to somehow optimize the algorithm to make it work. Eventually, you conduct a search. It will take some time, depending on the search technique, the algorithm selected, and you get maybe one or two or more good results. You will take the value of the parameters for this good result, and you will inject it back in your real model. And what happens, and this is testimony from clients, is that when you inject that given design in your real model, it doesn't behave as expected. Maybe because your surrogate model was not accurate enough. So this reaction you can see here are those from company who had understood a few years back the value of automation and optimization, so-called design space exploration, but they meet very, very much lots of difficulties, as you can see, errors, necessitate expertise. This is costly. So in the end, either they give up or they have just one guru of optimization, maybe someone who made a PhD in that domain, and that is fine. He's using that kind of solution, but it will limit the applications. You will not be able to deploy it in your company and really drive innovation with it. So based on that, this is how it came with an innovative solution, such as, again, the learning curve is not too complicated. So within Heeds, we have a solution called Sherpa, and I'll show you a bit more about that, where basically we tell you, well, keep your digital twin, your real model, use Sherpa, define your number of variables, define your constraints, define your objectives, and let the technology run based on your input, and it will suggest you good designs. And if you think about this solution, then it means that anyone can use it. Adoption is very quick. The Heeds training, introduction training is just 1 day. And at the end of the day, you know how to use it. And you can think now about more deployment across the different simulation and design engineers. So basically, the Heeds Sherpa technology is a framework that is hosting actually a lot of different algorithms, those coming from research, but it's using it a certain way, such as it's combining all these algorithms at the same time. To make it short, because we won't detail that today, you won't have to care about limiting the number of variables. We have clients using Heeds Sherpa with 10,000 variables. I'm not saying you should do that. They're using it, for example, in racing, in the racing car industry with 1D models, MATLAB models, or MSC models. I'm not saying you should use it with 10,000 variables. I'm just saying that you should not limit the number of variables because of the technology. We can do that. You don't have to do sampling. You don't have to create surrogates. You just have to use, again, your own variables. The only input that is required is the time. And actually, time is very important, I'm sure, when you have to meet milestones. And here, what you're defining actually in Heeds is the number of evaluation. Let me explain. An evaluation is one design. So imagine that you have a meeting in 3 days, so 72 hours. And let's say that the time for evaluating one model from the CAD to the results of the simulation, it takes 1 hour. It means you can perform 72 evaluation before the meeting. So you'll say, Heeds, okay, I give you 72 evaluation, such as I get the end of the study in 3 days. And Heeds will adapt. Sherpa will adapt the way we'll search the space and will do its best with that budget, 72 evaluations, to improve the solutions based on your input. So it will show you, it will give you results. You may be able to then share those results in your meeting. And if you've got an extra time, you could restart it, actually. So you can restart the study and give more budget, such as Heeds can you can see if Heeds can find other good solution in the design space. So this is very much a engineer-centric tool, again, because you're managing the time. It's not like you're just launching an optimization and you never know when you get results. Also, a great component of the Heeds Sherpa solution is that it's really collaborative work with the engineer. So you could just, again, you're the one, putting the data in, the expression garbage in, garbage out, of course. So you got to put a good digital twin simulation model as a baseline model, and you will define the variables and their boundaries. You will define the objectives. You will define the constraints. But also you can, at any time of the study or at the beginning of the study, you can submit your own ideas, your own design. So that's the idea. So you can inject your ideas in the study, and Heeds Sherpa will evaluate your idea. If it's good, it will help it to understand the design space itself. If it's not good, that's fine. It will also learn that it's not a good design based on the value of those parameters and so on. So this is really a communication in two ways between the machine and the engineer. This shared design technology can be used to select the best design of a first study and take it as a starting point for another study where you change some assumptions. So that's a very powerful tool, this shared design collaborative engineering feature that we have in Heeds. Let's look into a detailed example using Heeds in the electrification world. Here we are about to design an electric motor, and we have challenges, into maximizing the torque density, minimizing the torque ripple, maximizing the efficiency. And in that particular case, this is a 2D simulation connected with MotorSolve, Simcenter MotorSolve. That could be another tool. And the number of variables here is 10. What is automated here is that the geometry is in MotorSolve. It could have been in a CAD file and then pushed into MotorSolve. But here the process starts with MotorSolve, and then the data is sent to a specific calculation that could be in Python, it could be or any language. This is the get mass, and then it's pushed to Heeds to Excel to post-process the data. This is the workflow that is automated. So now what you see on the screen is a typical design exploration study where, again, Heeds orchestrates the changes of the parameters value within the boundaries you have defined. It will evaluate the performance of each design, and based on the performance of design, we'll take decision of changing the value of the variables and looping again and again until it improves the results. So there are a lot of different things you can see on the screens. Of course, dynamic visualization in Excel of the performance, but also you can see on the right, the lower right side, how the torque is being improved over the study. You see that it's starting at, let's say, 270, and it will increase along the search. And you can see that there are different, there are blue feasible designs, but you see also a lot of red crosses, and those are infeasible designs. So those designs mean they have violated constraints that were set up front, right? Those are designs that don't cope with your requirements. Still, Heeds have evaluated them, but where they are, and you could decide to analyze some of them and see why they've been violating the constraint. Have they violated a lot of with a high value of the constraint or not? So in this study again, we started from the baseline design here, and we finished there. So we really reduced the torque ripple ratio, and we increased the torque density. Well, you could argue, well, I've got experience in designing motors, I could have done it by myself. We don't say, well, that is not right, that may be true. But here again, you get more chances to get not only a better design, but actually more better design, because all those dots, which are on the corner on the right-hand side, are all good designs. So you could find more designs, you could get more data and more understanding of your your let's say design space and your product. Also, the more constraints you have, the more difficult it is to find in a trial and error approach. So let's now show you some different examples, different disciplines, first is just automating a workflow. Well, of course, we talk about innovation, but a lot of companies are also designing standard product, and it's the case here with ZF. They're designing control arms amongst different tools, different products. But control arm is a control arm, right? You won't make it like a crazy shape. It has always the similar shape because there's a lot of collision with different components on a suspension system of automotive car. And they had a certain process where, again, they would manually do stuff, right? They would start with the package given by their OEM, the car manufacturer client, and they would apply, their methodology into, starting from a design, using the simulation tool, assessing if it performs well and meet requirements, doesn't violate constraint. But it would take time. So here I've decided to use Heeds automation to automate the execution of their analysis, and as a result, they really reduced dramatically, their process just using automation. Now, if you think about, again, electrification, you think about, for example, system modeling. This is to show you that Heeds can be really used with very different kind of applications. Heat doesn't care about that, right? Heat is an orchestrator. It's executing tools. So here we're using an ACAM model, and again, you want to optimize, the sizing of this electric vehicle. You want a fast vehicle or fast accelerating vehicle. You want, of course, to maximize the range. And those are competing targets. And this is where, when you're doing a trial and error approach, as a human being, you have hard time to find those solutions. So here, Heeds will help you to find the best compromises, the best trade-offs, solutions to have, again, the best acceleration time and the best range. What is showed on the upper right of the screen is you can isolate clusters of families. You see this circle red, circle light green, circle green, and circle purple. So those are clusters of good solutions, and this is extremely important information you can share with the product, the team which is working on the product, and just take decision based on those information. You could also use Heeds to calibrate models against physical tests, right? If you've got hard time to calibrate your material law for a given material, and you've got test samples, you can use Heeds to drive the changes and match the simulation curve to the test curve. Same for if you've got a 1D model and it doesn't correlate very well with your testing results, then you can use Heeds for that kind of approaches. This is another example with a battery model. We have Heeds have been able to help that client to have a better digital twin of a specific battery model. If you're using simulation process solution, like in that case, Moldflow, you can use it as well. We've got a direct connector to Moldflow. But if you're using, for example, Moldec 3D, which is another solution, we don't have on-the-shelf portal, but we know how to connect it with the general portal, the general connector. That is not a problem. And here in that case, what is interesting is that not only we will improve the performance of the product, this is a Syring plunger, but also we will improve the manufacturing process itself, right? Because we will be looking at injection rate as design variables. We're looking at the molten plastic temperature, but we're also looking at the pack time, we're looking at the cool temperatures, and so on. So as a result of this study, not to detail it now, we don't have much time, is that not only we reduce the mass of this plunger, but also reduce the process time by 32%. This is extremely good results. It means that you'll be able to produce more of these Syrings, for example, for the same amount of time. So Heeds can be used in that domain as well, both on the product engineering simulation, but also on the manufacturing simulation aspects. Another example I like this story because it's showing execution of different tools. Here, this client is being they are in the turbine design, right? They're manufacturing turbines, and in this turbine, you've got combustion chamber. So this is you can see it on the scheme on the upper right of the slide. And in this combustion chamber, as you would expect, there are high level of temperature, and high level of temperature can cause cracks, right, on the chamber itself. So the idea here is that they want to reduce all the hot spots, and they're using what they called dilution holes. So they know that if they change the dilution hole geometry, the flow will be guided such a way that you can minimize those hot spots. So in the past, they were doing that manually. They were driving the CAD within Creo. They're using StarCCM Plus to do a CFD thermal analysis, and then they would export the thermal field to ANSYS to do a thermal stress analysis. But because all of that was manual, they could just only do a few iterations. Then they use Heeds to automate that, and Heeds and Sherpa to explore the design space. So what you see here in this animated video is that you can see that the Heeds is orchestrating the change of the parametric CAD within Creo. And you see the dilution holes geometry is being changed. And for each design pushed to StarCCM Plus, Heeds is executing StarCCM Plus to recreate the CFD models. Heeds is extracting the result from StarCCM Plus, pushing that as a boundary loading for ANSYS FEA, and so on. So this is quite a complex and long simulation, but at the end, they get a lot of value out of that because they are ready to reduce the temperature by almost 20%. And I see that time is flying. I've got a lot of examples. That's another example. This one I wanted to share it with you because that is from Malibert. It's about HVAC system, lots of constraints, and they couldn't find solutions doing manual approaches. What you see here, to make it short, is that if you see the pie at the bottom of this slide, there is a 96 out of the 100 design that Heeds has evaluated, 96 were not feasible, right? Because it was a very highly constrained design space, and that is why they couldn't find a solution. Well, still, Heeds could find design, right? Could find a good performing design. So of course, a lot of design were not feasible, but they could find it. With Heeds, they could find the design that were matching their requirement in only 3 days. So that is a lot of value. So again, if you think your environment is very, very constrained, you cannot find better than what you found out, you should still try to use such technology to find better solutions. In the aerospace world, we can use Heeds, right? This is an example, and I'm accelerating a bit because time is flying, but here we are working into a wing, into changing, the spar and ribs thicknesses, material, and also the wing cover. So that, again, those changes, if you think doing that manually, this is something that will take ages, and you would do just very few iterations. Again, using automation and smart design space exploration technology, you'll get to better solutions, and you'll be able to share more solutions, not only one design, maybe more designs from which the product team can make decision. I wanted to share that last example. I think I finished with the applications. I was mentioning in the introduction about plant layout or logistics. Well, if you have a simulation model, like here with plant simulation from Siemens, but other solutions as well, you can put Heeds on top of that simulation the same way you would do for an engineering simulation. And this is being now used more and more because those plant layouts have a lot of variables, a lot of constraints, and this is very difficult to find, the best solution. And in this domain, well, a lot of money and time can be spared if you use Heeds. Here the KPIs are, reduce number of containers on the line by 42%, reduce the material requirement by 17%, reduction of the production time per day is 20 minutes. That's enormous. So again, to keep the thoughts open, Heeds could be really used to design products, used to improve a manufacturing process if you're simulating your manufacturing process, but also being used on the plant, in the logistics, and so on. Right. I think I was a bit long. Sorry for that, but again, this is what you can do with Heeds. Non-disruptive solution that can plug to your existing CAD and simulation tools you're using, such as you can automate workflows, and in a second step, use our smart search technology to help you to find designs along in the design space. We have very different clients from different, of course, continents, very different industries. So some of our cycling maybe no Trek. They're big fans of Heeds for designing their frame, not only but their frame. You can see also some here. Brand Miller, they're more into military vehicle with heavy constraints, but also Bengton Dickinson. We've seen the example with the steering. So again, very large array of applications, but that all saying the same thing, right? They adopted Heeds because it's easy to use from creating the workflows and from the optimization side of things, because we make it easy with our optimizer Sherpa. Engage with Heeds. That's pretty much very, very straightforward. Installation of Heeds is like any application, could be done on your machine. And then this is about thinking about a pilot project. And when that pilot project is being defined, it's about training. So it's, as I said, it's just 1 day of training. And usually then we sell along with the training day, 1 day of mentoring, which is where we help you to get started on that pilot project. And then you let the technology run based on your input and the problem statement you've set, and you collect KPIs, right? When we're selling Heeds, we're not selling the ability to have a fidelity model. This part is done by the simulation solvers and solution by themselves. With Heeds, we sell you the ability to compress the development time. When we're selling Heeds, it's to help you to find better solutions. So you can set KPIs, and if you get positive KPIs, that will help to create a business case inside the company to invest in Heeds.